Hello guys, welcome back to my channel. Let's solve today's POTD. Today's POTD is not difficult, but there are methods, certain methods. Okay, so let's see first what is the POTD. So you are given an array that contains 0, 1, 2, and you have to sort the array in ascending order, increasing order you can say. And expected time complexity is order 1, order n, and order 1. So there are multiple possible ways to solve this problem. I am writing first is to sort directly. That will take order n log n. Okay. Second method is count 0, count 1, and count 2. Okay, you can count and then you can change the elements. So this will take order n because you are changing the element, just you are changing the elements. So this will roughly take order n. Okay, and space complexity is order 1 because you are taking only 3 variables count, and that but the but what will the problem, it will be, to be precise, it will be two order, and because for in one pass you will calculate count 1, count 0, count 1, and count 2, like for I equal to 0 to n. This way you will count now I, like n is the size of array. So if AR of I0 is 0, then count of 0 plus plus. Else if AR of I is equal to 1, then count of 1 plus plus. Else count of 2 plus plus. So for you will run this loop for to count the possible, count the values of count 1, count 0, and count 2. So and then next time for loop we will assign, like in starting, let's suppose count, like let's check example 1, 0, 1, 2, 2, 1. So here count 0 is 1, count to 1 is 3, and count 2 is 2. So what you will do, you will replace starting first value is with 0, and next three value is with 1, and then last two value with 2. So these you will replace. Okay, so for replacing them you will take one loop extra. Okay, so it will be order to an algorithm, right? Okay, I am not writing code of this, like you can write this way, like for pseudocode I am writing I equal to 0 to n. You can learn this technique from here. So you want starting count 0 element to replace with 0. So if I less than count 0, AR of I is 0. Okay, else if I less than count 0 plus count 1, then you can replace it with AR of I equal to 1, else it will be nothing but AR of I is equal to 2, because like first element till index 1 we will replace with 0. From index 1 to 4 we will replace with index 1, index 2, index 3, index 4. Till index 4 we will replace with, okay, till index 3, because 1 to 4, this is 4 and we are not including, so till index 3 we will replace with 1, and remaining will be 2. Okay, so this way you can replace the elements. Okay, so this is the another way. So what will the time complexity I have mentioned here, order 2n, it is 2n. So you will need to pass. We have best optimized method, that is the algorithm called destination flag algorithm. Okay, let's understand what is that algorithm tells. This question might be an interview problem. In the interview, no, you can solve this problem, but you want to know this method also, like whether you know this method or not. So that's national flag. Okay, Dutch national flag algorithm, right? What this algorithm says, there are three pointers. Okay, I, J, and K. What are these pointers? Till I, we have only zeros. Till I means not including I. Till I, we have only zeros. And from I to J, we have only ones. Okay, these are three pointers. What they are pointing. And after J, not including J, after J, till the end, we have only twos. Okay, this is the algorithm. Okay, so now when we are moving, we are increasing this j middle pointer. Okay, we are three pointer I chicken, we are increasing this pointer. Suppose we are at here, j is here. There are three possibility: we get 0, we get 1 here, and we get 2 here. Okay, if we get 0 here, what we will do? Here is 0. So what we will do, we will put this 0 here, because from here they are 1. Okay, here is an, okay, right. Okay, so including I, till before I we have only zeros, like this is I, so before I we have only 0. I to before j, like I including I, not including j. I to j we have ones, and now we are checking at j. I'm writing at j. Now if at j I am getting 0, what I can do, I can shift this 0 to here. Then what I will do, swap AR of I equal to AR of j. Okay, after swapping, what it will become, at I it will become 0, and here it will become 1. So can I say that now till I, now till index, can I shift this little bit I to next pointer, because now till here is 0. Initially till here was 0, but now after swapping here it became 0. After swapping it became 0. So now I will move, because this was, this will reach here, because till here is 0 before I na. So if I is 0, then I have to move forward, because what is this pointer before this, all 0. So if I is 0, I will move this to, I will move this one step. Okay, let me explain once again. Okay, this is the little bit tricky, or you can say crucial part of this problem, of this algorithm, I should say. Okay, because why this? Because we know this is our pointer. Before I we have ones, before I we have only zeros. So if I am getting 0 here, and I'm swapping here, now after swap, here it will be 0, and here it will be 1. And now what we have assumed, I will, before I there will be 0, so I should move forward here now. Then this will satisfy this condition. Then before I there all everything is 0, so what I will do, I will do I plus plus. Okay, and next thing is, here is also 1, so I can move j to next one, because before j is everything is 1. Before j, I to j. Okay, I to j minus 1, everything is 1, so I can move my j pointer. Okay, second condition, let's move to third condition first. If there is 2, okay, what if here is 2, what we can say? So there, if there is 2, nothing to do with this part. If there is 2, we can swap this to this. Okay, because we want all twos in the next, in the last, so we will swap ARR of j with ARR of k. And we are not, we don't know what is here. Okay, we don't know what we are traversing from this side and this side. We don't know what is here. So here it can be 0, 1, anything. It can be here it can be anything. It can be 2 also, okay, but we don't know because we are initially it will be n minus 1, because after n minus initially it will be n minus 1, because after n minus 1 there is nothing, so we can assume there are twos, okay. So we don't know what is at k. So after swapping, we will not move j, because we don't know whether at j it is coming 1 or 0 or 2. We don't know what is coming from this side, so we don't know what is here. So what we will do, we will only reduce k, because we took 2 from here and added. We took from here and added. Suppose there are nothing, we started in starting there is nothing, so k will be n minus 1, because after n minus 1 nothing remain. So what we will do, we will push this to here, okay. At a Now we can move this little bit. Now we will come to n minus 2, because we can say after n minus 2 till the n minus 1 there are only twos, okay. We are now we will now our k will be here, okay. So this, oh okay, sorry, this is the condition for this, okay. If I'm getting 1 here, so let me write again here everything I, before I everything is 0, including I 1 1. Here is a, we are checking here k, and after k there is 2 2 2 2. This is what is what pointer means. So if j we are getting 1, if AR of j is 1, what we can say, we can simply move to j to this now, because nothing to change with this, we don't need to swap anything, we can just move to this pointer forward. So this will be j plus plus. And what we will initialize in initially, we can say I equal to 0, we will traverse whole, and k is equal to n minus 1, 0 indexing case. Why? We can say or not before I, like before 0 there is only 0, we can say na, but there are nothing, but we can say ki before 0 everything is 0, and after k, after n minus 1 there is nothing left in the array start from 0 to n minus 1, but we can say like after n minus 1 there are only twos, but there are nothing, but we can say we can assume there are twos, okay, to maintain the properties. So this way, and we will start looping from here itself, okay. So this is the algorithm I have written the code. Total I have explained 3 algorithm. This is important for interview purposes. Let me show you the code here. I initialize with 0 and j initialize with 0, k is nothing but AR of size, that is n minus 1, while j less than k, until we hit the end case, like till we move beyond the array length, okay, array length, or you can say like we are traversing here some. Now we will move here. If we here don't need to do anything till here, we need to do, because after that there is no element, no array is not there now. So what we will do without array? So till here, so if AR of equal to j, swap with I and I plus plus j plus plus. If this is 2, then swap and k minus minus. Why this is not? Because we don't know what is coming from AR of k, because AR of k is in the end, and we have not traversed end side yet. So we are just decreasing k, and so after that we will still be at j. So we will again check at that j itself, and there what it will be, which will be nothing but there is, this is the case for 1, for the case of 1 we will just increase this. So this will only traverse the array once, each element once. So time complexity is order n, and we have not taken any created any array, created any array or vector. So space complexity is order 1, because we have simply created 3 variables and nothing else. So is this way we can do this. I will add the code, and I will add the code and article link in the comments. From me there you can also learn something. So thank you. Please subscribe my channel, support me guys.